it. We will see sometimes something that looks like this, N 55 degrees W. When we see that, that would mean 55 degrees west of north. What I first do in order to think about that angle net rotation, I think about this: north, south, west, east. It might help to draw that on your paper. And I'm first going to do an arrow in the north direction. So I'm going to start with an arrow heading north. Excuse me. So I'm first going to have an arrow heading north. And then the west means we're going to swing in the west direction. So we're going to swing west. So now if I'm swinging to the west is going to be this way. So I'll do my arrow like that. And this angle in between is 55 degrees. So we're heading north, but then we swung to the west, and that angle in between is 55 degrees. So now if we look at the next one, S 67 degrees east, it means 67 degrees east of south. So we're first going to start by heading south. So start by heading south. So we'll do a down arrow for the south. And then we're going to swing to the east. So the east is this way. Swing right. And then that angle in between is 67 degrees. Let's look at the first word problem that involves bearings. For this problem, it says a forest ranger at point A. So we'll draw a forest ranger. And we'll call this point A. Forest ranger at point A sights a fire directly south. So for directly south, we're going to do a line down this way. So there's a fire down here. So they see this fire directly south. Then says a second ranger at point B, 7.5 miles east of A. So 7, if I'm at A and I go 7.5 east of A, east is this way. So I'm 7.5. And that's where ranger B is. Now, ranger B sights the fire at a bearing of 27 degrees west of south. So we're first going to start heading south, and then we'll swing to the west. So they're going to start looking south, so that they're looking down, and then their eyes swing west. So we go towards the west. And whenever we stop, draw that line. Now, this angle right in here is 27 degrees, right? Right in here. So if I'm trying to find this angle inside here, and I know that these form a right angle, on the inside I would have 90 minus 27, which would be 63 degrees. So I'm going to set that up in here. So be careful, on the inside I don't have 27. I have 63 degrees on the inside. And we'll do right here. It says how far from the person A, is the fire. So what they want to know is how far from person A is the fire. So they want this distance right here. We can call that X. You have a few options. If I choose to work with this angle, a different color. If I choose to work with this angle right here, angle B, I know that the X side is the opposite side. 7.5 would be the adjacent side, and then over here would be the hypotenuse. So if I look at this, I want the opposite, and I need to use a side that I have a known value, and I have the adjacent side, and I'm describing in reference to angle B. So referring to angle B. So if we look at SOHCAHTOA, we have to decide which part of SOHCAHTOA do we want to use. So if I want O, I'm not going to use cosine. If I want O, both sine and tan of O, and I have adjacent, so I need to go with tangent right now because I want the opposite and I have the adjacent. And when we set this up, we'll say tangent of the angle we're using, which right now is angle B, or 63 degrees, is equal to the opposite of angle B, which is x, over the adjacent, which is 7.5. So then we'll multiply both sides by 7.5. Denominator cancels, and in your calculator, just make sure your mode is in degrees, and we'll do tan 63 degrees times 7.5. So x will be 14.72, and we'll throw in the units miles. So that's the distance from person A directly to the fire. Let's look at the next one. So the next one is similar. It's a different type of bearing problem. In air navigation, bearings are measured in degrees clockwise from north. So what that means, clockwise from north, if you watch the clock, right? The clock starts to tick and goes this way, right? 1 o'clock, 2 o'clock, 3 o'clock. So the direction clockwise, we say, is to the right. It's clockwise. And if you're going clockwise from north, that means you're looking north. North is this way, and then we spin clockwise. So that's another type of bearing for air navigation. So something like that. This one says an airplane flying at 600 miles per hour has a bearing of 62 degrees. Now notice the difference between this one and the last one. The last one might have said south 52 degrees west. So we would know it's 52 degrees west of south. But this problem just says has a bearing of 52 degrees. Well, they just said that with air navigation, you go clockwise from north. So we shoot up north and then we swing to the right in the clockwise direction. An airplane flying at 600 miles per hour has a bearing of 52 degrees. After flying for 1.5 hours, how far north and how far east will the plane have traveled from point of departure? So let's say that the plane is right here. And the plane, it says, has a bearing of 52 degrees. So we know that it says air navigation, we head north, and then we swing clockwise, and we'll stop, and we'll draw a line, and that in there will be 52 degrees. We'll create our right triangle. It says that after flying an hour and a half, how far north and how far east will the plane have traveled? Let's fill in a few things. First of all, right in here, this angle right here in red, is 90 minus the 52 on the outside, right? So we would get 38 right in here. We know that if the plane had the bearing and it swung this way, the plane traveled, and then it stops at its destination, right? This red line is the line, the path it traveled, the distance, right? It says the plane was flying 600 miles per hour. It was traveling for 1.5 hours. So right here in red, we would have 600 miles per hour times 1.5, because it was traveling for an hour and a half. So this distance that it traveled wasn't 600, it was actually 900, because it was going for an hour and a half. The 600 miles per hour is just how fast it travels in an hour. Now that we have this labeled, we need to figure out what we want. So they say that they want to know how far east and how far north this plane has gone. So we know up and down, that's going to be our north. This way is east representation. So I can just use the variables n and e to represent north and east. I'm going to come over here and draw another picture that's a little neater. So we have 38 degrees. I'm going to write n for north. I'll write e for east. Okay. This is 900. If I want to find north, if I choose to work with 38 degrees, I know that the north is opposite of 38. The 900 would be the hypotenuse. From SOHCAHTOA I want, in this case, the opposite, which is north, and I have the hypotenuse. So we'll see which one we need. So we want O, so we're going to cross off cos. We have hypotenuse, so we'll cross off tan. So we're going to use sine. Sine of the angle we're referring to is equal to its opposite, which in this case is north, over its hypotenuse, 900. And when we multiply both sides by that denominator by 900, let's cancel on the right, and sine 38 degrees times 900 will get us 554 miles. So that's north. Now for east, we're talking about east. If we're looking at this angle, right? East would be the adjacent. So now we would want the adjacent of the angle we circled, which was 38 degrees, and we have the hypotenuse. So if we look at SOHCAHTOA, if I want A, I'm going to cross off sine. If I have H, I'm going to cross off tan. So now I'm going to go with cosine. So cosine of the angle of 38 degrees is equal to east over 900. And when we multiply both sides by 900, we'll get that the east is 709 miles. Okay, I'm going to have videos for the other ones.